After you turn in your homework, these are a couple of warm-up problems. I'd like you to try to pause this video now and work on these on your own first. And in a second, I will go over them. So right now, pause the video. Now that you've had a chance to work on these on your own, I'm going to go over number 1. So we need to find g of f of x. Another way to write this is g of f of x. That's how you write it out in another way. Essentially what you're doing is you're taking whatever f of x is and you're plugging it in for x in g. So essentially this, you're doing almost substitution. You're going to plug in this entire x plus 1 in for x in g of x. So what this looks like is, instead of writing x squared in g of x, you're going to write whatever f of x is. So I'm going to write x plus 1 here, and x plus 1 also over here. So notice this x plus 1 from f of x is replaced instead of x in g of x. So this was a little challenging with all the algebra here. So remember, when you're squaring a sum, you need to write it out. Right away, I'm just going to distribute this 3. So I get 3x plus 3 and then plus 2. And then I'm going to distribute out this next one. So I get x squared, x, and 1. And now I'm going to combine like terms. So I have x squared. I then have 5 x's and a 6. Since I can no longer simplify it, this is the answer for g of f of x. So in the blanks on the quiz, you're going to write out x squared plus 5x plus 6 as your answer in the blank. For the next one, it's essentially the same thing. Okay, so we need again to find g of f of x. And you're going to do the same thing. So to find g of f of x, this one just kind of throw you off a little bit. You're going to plug in what f of x is. So this 3x squared in for x in g of x. So you're doing substitution, essentially. So this 3x squared, that was f of x, is now replaced for x in g of x. So now you're going to simplify this. So this would be 21x squared minus 5. Since you can't simplify this anymore, this is what you would write in the answer blank. So now what I'm going to do is do some of the book problems that you're going to have for homework. You might finish them in class, but I'm going to do some of them for you just as a review. So number 36 is one of the problems in the book that you'll have to do anyway. So it's to your advantage to write this one down as well. So take a second to write that down. And then now I'm going to simplify it. So when I look at this, I notice they both have 1/3, but the 16 and 4 you can actually reduce. So this one might be a little harder to see, but 16 is actually 2 to the 4th power. And that's what I want to change this to right away. And then 4 is 2 to the second power, 2 squared, and that's also raised to the 1/3. So I'm going to use my exponent rules to simplify the 4 and the 1/3. So this is going to be 2 4/3 times, and then this would be 2 2/3. Next, I'm going to add these exponents together. So it would be 2 to the 4/3 plus 2/3. And what that ends up being is 2 to the 6/3, which is really 2 squared, which is 4. So completely simplified, number 36 is the answer is 4. The next one I'm going to do is number 42. So this is one with variables. What I do first is I attack these negative exponents inside the parentheses, and then I attack the negative outside the parentheses. So when I have a negative exponent in the denominator, I need to move it to the numerator. So what this really looks like now is I still have x to the 4th, but now x to the 1st power is now on the numerator for moving it. So when I combine these two, what I'm left with is x to the 5th. Now I'm going to attack the negative exponent outside the parentheses. And when it's outside the parentheses, I move everything in the parentheses either to the denominator or back to the numerator. Since this is in the numerator, I can rewrite this as 1 over x to the 5th, all to the 1/5 power. And then when I distribute that 1/5 power, I'm left with 1. And just to show the step, it would be x to the 5 over 5, which is just 1. So my answer would be 1 over x. And that would be simplest form. I know it's in simplest form because there are no negative exponents. Another one I'm going to do is 48. What makes these problems quite a bit of work is that you need to check for those extraneous solutions. So the first thing I need to do is get that radical alone. So I'm going to add 1 to both sides. And next, to eliminate that radical, I'm going to square both sides. So if this was a cubic root, I would cube both sides. A 4th root, I would do to the 4th power of both sides. Since it's just a square root, I'm going to square it. The reason is that these two operations are to each other, and I'm left with 3x plus 3. And here is not x squared plus 1, but keep in mind that when you're squaring a sum, that's really what it looks like. So I have to use the distributive property to get x squared plus x plus x plus 1. I'm going to combine like terms. And notice I have a quadratic that I'm going to have to factor, so everyone's favorite. So if I'm going to factor this, I need the set equal to 0. So I'm going to move over my 3x and my 3. So I'm left with 0 equals x squared plus negative 1x or minus x and negative 2. So now I'm going to have to factor. So x times x gives me x squared. And I need, what times what gives me negative 2? When I do all my distributing, I will get a negative 1. That's a minus 2 and plus 1. So next to solve, I'm going to set each equal to 0 and solve for both. So I have 2 and negative 1. So on the test, there's going to be blanks for the actual answer, and then there'll be a blank for extraneous solutions. So notice it says check. You won't get full points if you don't check. So what I'm going to do is do that. Just to give me some more room here. And make sure you plug it in the original equation. So I'm going to check x equals 2. So I take square root 3 times 2 plus 3 minus 1. Does that equal 2? That's what I have to check. So I get the square root of 6 plus 3, and which is 9, which is 3 minus 1 is 2. So that checks. So in the blank, I would write x equals 2. Now I'm going to check x equals -1. So I'm going to plug it in the original, equation. So I get -3 plus 3, -3 plus 3 minus 1. I get the square root of 0 minus 1. And sure enough, the square root of 0 is just 0, and that one checks as well. So there would be no extraneous solutions on this problem. The last one I'm going to do is number 57. So there will be ones like the warm-up on the quiz, but also ones where you have to figure out a value. So you're going to be given two functions and this kind of notation. Remember, this same notation is the same thing as looking at this. So the way I solve these is I first figure out what g of -1 is. So g of -1, I'm going to take g of x function, so 5x minus 2, and I'm going to plug in -1. So when I plug in -1, I get -5 minus 2, which is -7. So g of -1 equals -7. Okay, so this whole thing equals -7. So now what I'm going to do is I'm going to substitute, instead of having this g of -1 here, I now know that -7 is what g of -1 is. So I'm substituting -7 in for g of -1. So all I did is substitute here. So h of -7 equals, if I look at this function, they do -7 squared plus 1. So I get a positive 49 plus 1. So my answer is 50. So my total, or what I would write in my answer blank, is h of g of -1 is 50. And that's my answer. So the rest of the time is yours to work on your homework assignment. Like I said, some of them I've already done for you, so you can look back in the video. Otherwise, as you're doing your work, check your answers in the back of the book. That's so you know you're doing it right. Remember, I will be before school tomorrow morning at 7 if you have any other questions, but the rest of the time is yours to work.